Hello, and welcome to the lecture on Chapter 5, which is on measurement. In this lecture, I'll be talking about reliability and validity in some depth. Starting with the idea of reliability. Reliability is looking at a variable and trying to see, is that variable or that assessment tool consistent? And what we mean by consistent is that if we have this variable and we're looking at it, when we measure it, could this be done repeatedly and yield the same results each time? If we were to look at a variable and try and assess whether it's reliable, we would expect that variable that each time you conduct your experiment would be able to result in a similar fashion if the data was the same. One of the reasons we'd like to have reliable variables within our experiments is that we have less variability, or less what we call error, within our sample. So one of the things that you may need to do when you're conducting your experiment is to actually check and see, are the manipulations that you're doing, are they reliable? And there's three main ways we can do this: looking at internal consistency reliability, test-retest reliability, and inter-rater reliability. Let's start with internal consistency reliability. Internal consistency reliability is where we have our instrument and we could possibly be measuring it multiple ways. But when we measure it, we're looking to see, is it internally consistent when we have multiple scores? For example, let's say that you're giving somebody an anxiety scale. And on that anxiety scale, it has 10 questions. And let's say 1, 2, 3, all the way down to 10, right? What we're hoping is that these 10 questions are all measuring anxiety, but they're doing so in slightly different ways. So it's not like the same question is being asked every time. Instead, the questions are slightly different, but they all get at the same conceptual idea of anxiety. How you know if you're actually reliably asking about anxiety is you want to go ahead and see, are these questions here related? And you do so by looking at something called coefficient alpha. This is also sometimes called looking at split half reliability. All this is a statistical way of determining our internal consistency. How reliable is this measure by looking at the individual questions? Technically, coefficient alpha is the extent to which subscores on half of our instrument correlates with the other half of the scores on our instrument. So, for example, we could take questions 1 and 2 and correlate all of our participants' scores on questions 1 and 2, and they should be somewhat similar. Same for questions 1 and 3, 1 and 4, 2 and 3, etc., right? If by chance you found that questions 3 and 4 were not highly correlated, well, now we'd be concerned. Now, maybe these are not actually measuring anxiety. Maybe they're measuring something else. And in that case, we'd be concerned about the reliability of our measurement. So how do you know if you have good internal consistency? Well, you're hoping for a value that's at least 0.8. 0.8 to 0.89 is good internal consistency. Excellent would be 0.9, or of course above, all the way up to 1. Whenever you have a value lower than 0.8, that's considered fairly risky. These are unlikely to be strongly correlated at this point. The other thing you may be concerned about is what happens if you do this correlation and you get a negative value. That is, remember that as one variable increases, the other decreases. Well, that would be bad news, because in our case, we're hoping that these variables are positively correlated. That is, as one person's score on question 2 goes up, so would their score on question 3. Only positive correlations are desirable when looking at our internal consistency. Now that we've talked about internal consistency reliability, let's move on to test-retest reliability. Test-retest reliability does just what it sounds like it does. You test somebody once, and then you retest them. So this requires giving our measure, our variable, to the person twice. And we want to do this fairly close in time, for example, no more than maybe 2 or 3 weeks apart. Then what we do is we want to correlate these two testing times. Do the scores positively correlate with one another. What we're hoping is that we end up with a correlation of 0.8 or above. Again, excellent would be 0.9. And what we're seeing is how stable is this variable over time. If somebody is testing in the same way on the same variable over time, we know that it has good test-retest reliability. For example, let's say that you have a participant that's taking the Beck depression inventory, and on January 1st they take it and they get a score of 27. A couple weeks later, January 12th, they take it and they get 25. Their correlation value here would be 0.88. This would be a highly desirable test-retest reliability rate. Whereas if you had somebody taking the Dunlap DI on the same time, January 1st, and get a score of 28, but then a couple days later they take it again and get a 3, well, now our correlation between these two values is 0.2, and that is simply not high enough. We'd be very concerned about the ability of this test to reliably test-retest consistently over time. So that would be our information about testing and retesting reliability. Let's move on to inter-rater reliability. Inter-rater reliability is looking at the ability for two observers to agree when they're observing some particular behavior. The ability for observers to agree on an observation. Let's say, for example, that you're doing an intervention with a child who has autism, and this child who has autism is playing with other children. And what you want to do is you want to count the number of times that our child here engages in a social behavior. And so you're going to watch this child play. So you have two of your research assistants watch this child play. And what's going to happen is each of these people on their little clipboard here are going to record the number of times they see a social behavior occur. In order for you to see if they actually have good inter-rater reliability, what you would do is you would compare the number of times that each observer sees a social behavior occur, and then divide that by the number of opportunities to agree. Multiply that by 100, and what you get is the level of agreement these observers have of the number of social behaviors displayed by the child. When we're looking at inter-rater reliability rates, we're hoping for an inter-rater reliability rate of 85% or more. Anything less than that is generally not considered acceptable. Generally, that means you would have some sort of problem defining your behavior, your variable of interest, in this case, number of social behaviors. Now let's look at an example of what would happen if we had low inter-rater reliability. Let's say that we are looking at our research assistants, Jim and Alice here, and they're both observing little Timmy for symptoms of ADHD. Timmy's running around, playing with multiple toys, turning the TV on and off, and looking out the window. Jim ends up rating the level of ADHD as a 4. He just says, boys will be boys. Whereas Alice rates the level of ADHD symptomology as a 10, which would put him as very distractible and hyperactive. This would be an example where we have very low inter-rater reliability. And that concludes our lecture on forms of reliability. Let's move on to the idea of looking at the validity of your assessment instruments or your variables. Validity, of course, has to do with the idea that whatever you're using to measure your variables is actually measuring what you intended to measure. And we think of reliability and validity as being somewhat related. Reliability is a necessary precondition for validity. If our instrument lacks reliability, we also know it lacks validity. However, just because something has good reliability doesn't necessarily mean it has good validity. So, how do we assess the validity? Well, one of the most common ways that people like to assess the validity of variables is by looking at what we call face validity. And this is the idea that whatever test you're using appears to actually test the variable of interest. It has some sort of conceptual, definitional relationship. Essentially, does our test look like it measures what it's supposed to test?